That's one thing I can say. You were smarter than everybody else because you're sitting there working on it the whole time, weren't you? Problem 15. They give us a pattern, 1/3. That's why David wanted to see it worked, wasn't it? Oh my goodness, it's got a fraction in it. Might die if I do anything with a fraction. Doesn't matter if you like them or not, they're part of life and you gotta deal with them. I hate have to get out of bed in the morning, but gotta do it.
No, in the morning first.
This is an easy one too. What do they do each time? I'll give you a hint, it's just adding. They add how much? 2/3 every time. So what's the next one gonna be? 3 and 2/3, just add that one. Next one.
RV teachers for the direction at this time. I need all sophomores getting retakes. All sophomores getting retakes, please. Down to the cafeteria.
Must be going pretty quick.
19.
19. Problem 19. Figures you'd ask me one that I can't really draw. So we got several different ways you can do ones like this. Did it, that's terrible. Perfect.
It's okay.
Several different ways you could do ones like this. I'm just gonna write third one up here because I'm not even gonna try to draw it. You could look at the pattern as far as how many blocks they're adding each time. You could just look at the different stacks, the different levels. All right, on this one, I don't know. So how many blocks do we have in the first one? 1. How many blocks in the second one? Be careful. 5, everybody agree with that? How many blocks in the third one? How many? 15? 14? Then we want the fourth one, right? That's what we're looking for. What's going to be the fourth one? Can you see a pattern there?
Yeah, it kind of just puts the one that was there on top and then adds the next level.
All right, so maybe on this one, we do need to go by the levels, right? Here we had 1 block, or 1 level, 1 block.
RV teachers for the direction. All juniors at this time. All juniors need retakes.
Here we had
Go down to or
The
to
top
cafeteria,
level was
please.
1-1, the next level was 2x2, right? So the second level was 2x2. What was it here? First level was 1, second level 2x2, third level was what? 3x3. What's going to happen on this one? The fourth level is going to end up being 4x4, right? Well, if it's 4x4, how many blocks are we adding on to that? 16, right? So you just take that 16, add it back to this, how many blocks would be in that fourth level? 30. I'm not sure what they asked you because I didn't read the directions. Make a conjecture about the number of blocks in the next, okay, so I did it right. So how many, our conjecture is going to be there will be, how many blocks? 30 blocks in the fourth figure. That would be our conjecture. There will be 30 blocks in the fourth figure. Next question.
23.
23. 23 says, make a conjecture based on the given information. Draw a figure to illustrate your conjecture. So 23 says angle 3 and angle 4 are a linear pair. Can you just forget all that stuff that we learned way back in chapter 1?
No.
No, as a matter of fact, that's the important stuff. You're going to use it a whole lot more than you use like the translations or anything throughout the year. You got to know what a linear pair is. You got to know what collinear is. You got to know what a plane is. You got to know how to name an angle, all that different stuff that we learned in chapter 1. If angle 3 and angle 4 are a linear pair, let's do this. I'm going to draw angle 3. Then I'm going to change colors. Somebody that thinks that they can draw angle 4 for me, come up and draw it. To make a linear pair, what's it mean to be a linear pair? Together they form a line. Somebody go up there and draw angle 4 for me before I pick somebody. They share a ray. They share one side. I got it. I give you credit. Make a couple more left there.
Yeah.
Is that right? Yeah. Linear pair. They form a line together. Okay? What else do we know about those two angles? Together they add up to be what? 180. What's another name for that then? Starts with, what is it? Supplementary. All right? What did they ask us to do here then? Draw the figure, illustrate conjecture, make a conjecture. So we know angle 3 and angle 4 are a linear pair. Well, we just got done saying one. What else do we know about angle 3 and angle 4? Angle 3 and angle 4 are supplementary. That's probably the best one, the one that we would actually use, because that tells us that they have to add up to be 180. So if I knew that this one over here was 30, could I find angle 4? Yeah. If I knew that angle 3 was 5x, angle 4 was 3x plus 10, could I set up an equation to find both of them? Yeah, those two add together should equal 180. Next question. This is all we actually needed on that. 29. Determine whether each conjecture is true or false. Give a counterexample for any false conjecture. Remember, the given information, that's what you know to be a fact. All right? Anytime you see it says given, we know that to be fact. Then the conjecture, or whatever it says next, a lot of times they'll say conclusion. That's what we're trying to decide or show is true. So in this case, we know that angle 1 and angle 2 are complementary angles. So I'm going to write that down. Angle 1 and angle 2 are complementary. What's it mean to be complementary angles? We just talked about supplementary. What's complementary mean? They add up to 90. So then what we're trying to prove, or what they're asking us is, do angle 1 and angle 2 form a right angle? We're trying to decide whether that's true or not, whether they form a right angle together. All right, so if Levi draws this, because when we're dealing with complementary angles, we usually have something like this, right? Well, if he draws that picture, do they form a right angle together? Now, here's where you got to be careful. Did they tell us to draw that picture?
No.
No, what did they tell us? Angle 1 and angle 2 are complementary. Did they tell us they had to be adjacent to each other? So could I draw angle 1 here and say it's 30 degrees? Angle 2 here and say it's 60 degrees? Are those two angles complementary to each other? Do they form a right angle together?
What? No. Are together?
No, because they're not together, right? So is this a true or false statement? False. Now, is it always false? No. But how many things does it take to show something's false? One. One counterexample. Well, that right there would be our counterexample. Can you read that? Perfect. That great penmanship.
Looks wonderful. I love it.
Now, and this is what you got to be careful of. They give you some information, just because whatever pops into your head first, does that mean that's the only way that information could be set up or used? No, there's many different ways. So this one, true some of the times, not all the times.
Pardon me, teachers, for the interruption. At this time, I need seniors with last names C and D, last name C and D, down to have their picture taken, please. Thank you.
Next question.
38.
38. 38. Make a conjecture about butane, which is the next compound in the group. Write its structural formula. So a little science lesson here. You can go to Mr. Swihart or Mr. Bryan
Let's go.
or Ms. Hoffman today and say, hey, we learned about methane, ethane, propane, butane, all that stuff in math class today.
Mr. Swihart tries to give us math lessons all the time.
That's good. Tell him I appreciate it.
Why, he's not very good at it. He always says, this isn't my field.
Anybody, the next one they're saying is butane. Somebody tell me the chemical name for butane written that way. Think it's gonna have like an A in it? No, it goes in a pattern, right?
Yeah.
So what's it gonna have?
C.
C,
H.
an H, is that it? There's gonna be numbers with them, right?
Yeah.
Anybody remember for science class, what's those little numbers tell you?
Electrons.
Sorta. Tells you how many C's and H's there are, right? So how many C's are in this first one?
1.
One. How many C's are in this second one?
2.
Two. Anybody remember what the C stands for? Science class? Carbon. What's the H stand for? Hydrogen. So you mix carbon and hydrogen, you get some kind of gas, right? Methane, whatever all those are, we're looking for butane. So it's not just CH. What else do we need? What's going to go down here at the bottom of the C? 4. How come 4? What's the one here?
+1.
1.
2. 4. 2, 4. So that'd be 10.
10. Says make a conjecture about butane, which is the next compound in the group. Write its structural formula. The conjecture you could make a whole bunch of conjectures. This is its compound formula, so that's half our answer. Give me a conjecture about it. Start it off, butane, what? Tell me something about butane. We can say it's flammable from what we've learned.
There is 4 carbons.
Butane has
4 carbons in it.
4 carbon atoms.
Yeah.
Good enough. Levi was gonna make it longer than it has to be, Roy, but then he was gonna say, and 10 hydrogen atoms, right? Do we need to know all that? No. Would it be wrong? No, that's just more information than, they didn't ask us to write that much, so I'm not gonna write that much, but you could. Next question.
40.
40. Develop a rule you could use to find the chemical formula of the nth substance in the alkaline group. So let's look at what we have here. The nth substance, this is the first one, second one, third one, fourth one. That's what N stands for. N is the number that you're dealing with, whichever one.
Pardon me, teachers for the direction. At this time, I need the following students. Joseph Allen, Chris Brubaker, Jaden Kenworthy, Jacob Schaefer, Brianna Cowan, Logan Hofacker, Mackenzie Reich, McKenna Brower, Chris Dane, Dylan Hager, Dominique Huffman, Riley Roberts, Tara Strobe. Down to the office, please. Thank you.
What do you notice about, this is our first term, second term, third term, fourth term. What do you notice about whatever term we're on? That's the same as what? How many carbons, right? So if I'm looking for the nth term, guess what's going to go right here below the C? N. Now we got to figure out something for H. That's a little tougher. What is that?
N times 2.
N times 2?
Plus
N plus 2? You're adding 2 each time to the H, right? Well, how are we going to do that? Because if you just put N plus 2, does that work? What was in here? 1, what's 1 plus 2? That doesn't give us that, does it? So somehow we need it to, what can we do there?
N plus 2 should be.
What if you did this? What's 2 times 1? 2 plus 2? Hey, that gives us that one, right? Now, does that mean it works for all of them? Who knows? Let's try it. Next one's the second term. What's 2 times 2? Plus 2? Hey, it worked for that one. How about this one? What's 2 times 3? 6 plus 2? Did it work for that one? Is it going to work for all of them? So that's answer number 40. A little tougher on that one. You had to come up with the actual thing. So who knows? Looking at these, they're all butane, methane. So let's say we go way down the line. I don't know anything about science, so zonane. Maybe that's a gas in this setup of gases, all right? And maybe I tell you it's the 20th gas. It's the 20th gas in the list. Could we go back and figure out how many carbon atoms and how many hydrogen atoms it has in it? Yeah, how many carbon atoms would be 20? How many hydrogen? 42. I'm sure there is a gas that has that in it. It's probably not called Zonane. I don't know, it's the name I just made up. Other questions? Hurry up, Max can't handle it, he's falling asleep already. 44? 44. If the average of 6 numbers is 18 and the average of 3 of the numbers is 15, then what is the sum of the remaining 3 numbers? I was helping somebody with an ACT practice test the other day. There are a bunch of them, and they had a whole bunch of questions just like this. Is there anything difficult about finding the average? No. All right? But they put stuff like number 44 here on there on the ACT because they don't want to know if you can just add them all up and divide by how many there are. They want to know if you can use that information and figure out things about the set of numbers. All right? How many numbers did they say we had? 6. So watch what I do here. How many blanks did I put there? 6. They told us that all 6 of those have an average, or average out to what? 18. So I'm just going to put A equals 18. That's the average, we'll say. Let's probably, I'll not put A because that's not a good way to. So the average is 18. So we need to sort of work backwards and sort of figure out what our list here is. Well, if you have 18 is your average, what did you have to do with all 6 of these? Add them all up and divide it by 6. So if we added them all up, whatever the sum was, and divided by 6. Well, let's go backwards. That's what gave us 18. If we work backwards here, how could we find the sum of all of them? 6 times 18. Somebody help me out with the calculator. You multiply both sides by 6. The sum of all 6 should be. Is this hard so far? Take a whole lot of math knowledge? No, this is the kind of stuff they put on like an ACT test. 128? Because they want to know, hey, can you use your brain to work things backwards and do things that aren't exactly the same thing?
Since I have to take that tomorrow and have it studied.
So all 6 of these add up to 128. Then they tell us that 3 of them have an average of how much? What'd they say, 15?
Yeah.
What are we going to do with that then? Sum, oops, not 3 this time, not 6. What do you multiply both sides by? What's 3 times 15?
45.
All right? So all these add up to 45. All these over here, or all 6 of them added up to 128. How are we going to find the sum of the 3? If these were the 3 that came down here, how are we going to find the sum of these remaining 3? Not times. You knew that the sum here was 128. The sum here is 45. How are you going to find what these 3 add up to be? You guys make it harder than it is. Minus 128 minus 45. What's that give us? $83? So what's these last 3 numbers here add up to equal? 83. And that's all they asked us, wasn't it? What's the sum of those other 3 numbers? Did they ask us to find any of those 3 numbers? No, just what's the sum of them. So we know that these 3 numbers add up to be 83. Was that one of the answers on there? Wow, what did we do wrong? If the average of 6 numbers is 18, the average of 3 numbers is 15, then what is the sum of the remaining 3 numbers?
I can tell. Me too.
Yeah.
Yeah, shut up.
What did we do wrong?
It looks right.
Can we take that now?
No.
Okay.
Did you guys multiply wrong when we started out? 18 times 6?
I don't wanna late.
I don't even think we.
Oh my goodness. Somebody told us the wrong answer. It's 108. Now what do we do with that 108?
Minus 45.
Minus 45. What's that give us?
I really don't even think we had to do this problem.
63. Yeah, we did.
Wow.
Not according to.
18 times
Google.
6 is what? Probably Robert that told us wrong, wasn't it?
Yeah, Robbie would.
Not according to Google, we didn't.
Pardon me, teachers, for interruption. At this time, I need seniors with the last names E, F, or G to go down to have their pictures taken. Thank you.
If you ever saw it. Come look on it. I got one dentist house, but like, 4 months.
Better start doing this one time.
See, I'm not 30,
Better start doing it.
You know, your Moodle is wrong, Mr.
I have to
Everson.
check it because I thought I fixed it.
Because it said we only had to do the 43.
Oh, okay, so pretty cool. Is this home?
I think it was.
Is that 43?
Because I thought I fixed it. Maybe I didn't fix it on Google. Maybe I fixed
So
it.
11.
I fixed it on the PowerPoint.
11 through 21, 23, 26, 30 through 38.
Pardon me again, teachers, for the interruption. I need any underclassmen who has not had their picture taken, needs to go down at this time. So even if you're not ordering a packet, please go down at
These are
this
your
time
notes
and
for
have your
today?
picture taken. Thank you.
Let's see. What do I want to title them? Let's title them,
You're not writing them?
you want to write stuff on them.
Yeah, okay.
Just put, let's just put this as a title. I left my marker on. Let's just put 2-2, 2-3. Or actually, just put 2-2, that'll work. 2-2 notes. That's what it's labeled on Moodle. We're gonna go through this together. Probably wanna jot some stuff down anywhere that you can find a little space to put some stuff in. Make sure, please make sure these notes get into your binder where they belong. And also, I ran the notes off for you, so when I check them, am I just gonna give you credit because you got these stuck in your binder? No, if you don't write stuff down on them as we go through them, no credit. I'm not giving you credit for me running off copies. That doesn't make any sense, right? So make sure that you write stuff down as we go through them. Don't let me forget at the end of class to pass those out.
How do you make these pretty? So tempting. Like making them pretty. Pretty with highlighters.
Zebras.
You're stupid.
Put this down, I don't know, on the bottom somewhere, put something off to the side, put your blanks. Leave a little space for reflection that you can write it in there somewhere. You could actually write it on the back of the second page because there's nothing on there, so if you wanted to do it there, you could, that might be better maybe.
I feel like they need to make them.
You could title it this too, I didn't even realize, conditional statements. That might be a better title than 2-2, conditional statements. I knew there was something that I wanted to name them, couldn't remember what it was.
Can I make them pretty?
What knowledge do you have about conditional statements right now?
Say about 2.
2? So maybe put a 2 in that blank. We'll fill out the rest of it here in a little while. Right, first thing. Remember, a statement is any sentence that's either true or false. Another name for a statement is a what? What did we call it yesterday, 2 days ago? A what? Conjecture. So that's a statement. Anything that's either true or false. The truth value, these are all real difficult. The truth value of a statement, if they ask you, this is some of the math people trying to sound high and mighty or something, they'll say, find the truth value. All they're meaning is tell whether the statement is true or false. So you're just telling if it's true or false. That's all you're doing for the truth value. A negation, and we'll use stuff like this a lot. This right here. If I say the statement is P, all right? If I say the statement is P, that's just meaning I'm being too lazy to make up a statement, and I just want to use some letter to stand for the statement. And Max is laughing, but he'll enjoy it when they use P and Q and R as a statement, because that means less writing. Right? It means you got less work. If the statement is P, the negation of that statement is just not P. Alright? So if I say it is raining, the negation would be what? It is not raining.
Does it have a symbol?
And it does have a symbol, and we're getting ready to write that down right now. The symbol for a negation, is a little tilde. Alright? It's like half of the congruent symbol, right? The congruent symbol is that little tilde with the equal sign below it. Well, negation is just the little tilde. So if I made up a statement and I said, A is my statement, and I wanted to negate it, I'd write it with the little tilde out front, and then A. That means not A. Compound statements is putting two or more statements joined together. So if I say something like, it is raining outside and the sun is shining. That's a compound statement. Right? So two or more statements put together. Two different kinds of compound statements. One's a conjunction, one's a disjunction. You hear these words in English class, right? They mean the same thing in here almost. Just a little difference. They still mean the same thing, but they're used a little different. A conjunction uses the word and. So a conjunction uses the word and. So if I say, it is raining outside and the sun is shining, that's a conjunction. The symbol for a conjunction. It's like that upside down V. So make sure you write in that symbol and know that. Oh, is it on yours? Oh yeah, it is on yours. Ain't on mine. So the symbol's that upside down V. Now the way I remember the difference between a conjunction and a disjunction and what they use, conjunction uses the word and. This almost looks like a what? It almost looks like an A, but I forgot to put the bar in. Alright? So maybe that'll help you remember. Disjunction uses the word or. So if I say, it is raining outside or the sun is shining. Completely different statement. The symbol for a disjunction, that symbol turned over. So it's like a V. If I give you a conjunction, listen carefully to this, because I'm going to ask you to answer a question here, so Wade wants to perk up for a minute. If I give you a conjunction, I say, tonight I am going to the movies and I am going to eat out. I come back on Tuesday when I see you guys again, and Robert says, what'd you do on Friday? And I said, I went to the movies. Did I lie to you today? Yes. Not kinda. Think about what your mom would say. Would your mom say, yeah, you kinda lied to me, but I'm gonna let you get by with it? That's not the way it works, is it? No. You tell your mom, hey mom, I'm gonna run to the store, and then you come back, and she said, where you been all this time? Well, I ran to the store and I went to Bob's house. She's probably not gonna be too happy, right? Because you lied to her. You're gonna say, well, Mom, I told you it's truth. I went to the store. That's not the way she's gonna take it. All right? When you give a statement that has a conjunction in it, so I told you I was going to the movies and I was going to eat out, how come you came up with the idea that I lied to you since I just went to the movies? I didn't do both, right? When you use the word and, both parts have to be true for the whole statement to be true. Does that make sense? Both parts have to be true for the whole statement to be true. Now, what if I change it? Tonight I am going to the movies, or I'm going to eat out. Tuesday I come back and I tell you I went to the movies. Did I lie to you? No, now I told you the truth. Right? Because I said I was going to do one or the other. So, with a conjunction, for a conjunction to be true, both parts have to be true. A disjunction to be true, only one part has to be true, and then the whole thing's true. Okay? So they're going to ask you to decide whether conjunctions, disjunctions are true or false. And you got to know, hey, for a conjunction, both parts have to be true, or the whole thing's false. Disjunction, only one part has to be true. A truth table, if you look back here on the second page, those right there are called truth tables. They look real difficult, and everybody seems to make them out to be real difficult. They're not near as hard. If you just watch how to do them, they're not near as hard as they look to be. And we'll talk about truth tables here in a few minutes. All right, a conditional statement. This is very, very important. Might want to put an asterisk out beside that. Very important.
Pardon me, teachers for the direction. At this time, I need seniors with the last names H through L. H through L, please come down and have their pictures taken. Thank you.
A conditional statement is also called a if and then statement. Conditional statement is also called an if and then statement. Guarantee there's a problem on the final exam that says a conditional statement is also called blank. And you got to fill it in. It's also called an if and then statement. The reason it's called an if and then statement is because you can write a statement in that form. If something, 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 comma, then something, something, something. So here's one up here. If it is raining, then the grass is wet. That's a conditional statement. In any conditional statement, the if part, the part that comes right after the if, so in this case, what comes right after the if? What comes right after the if? It is raining. That's called the hypothesis. That's called the hypothesis. All right? Now, a little different than what you're probably used to, hypothesis as far as science class goes. All right? The hypothesis in here is the first part of the statement, and it's the part that you're taking to be fact. It's the part that you are taking, hey, this has to be true. Now I got to decide, is this second part true or not? And that second part comes after the then statement. So what's the second part here that comes after the then statement? Somebody read it to me. The grass is wet. That's called the conclusion. Very, very important that you know this. If you look back in the back of the book, and we're going to get to some of these theorems and postulates here pretty soon. You look back here, almost every single one of them is written as if and then statements. If an angle is a right angle, then we know it's 90 degrees. All right, so if and then statements, also called a conditional statement. Very, very important. Here we got this. If two angles are vertical, then they are congruent. What's the hypothesis in that statement? Two angles are vertical. So we know these two angles are vertical. What's the conclusion that we can come up with? Then, or not then, they are congruent. That's our conclusion. That's our hypothesis. Got to be able to pick that out. Looking down here, notice, got lazy. What's the hypothesis in this statement? If P, then Q. P. What's the conclusion? Q. Guaranteed on the final exam also. So David's going to watch this closely because this is very, very important right here. Converse, inverse, contrapositive. My son was just working on this in his geometry class last night. Not hard, just hard to remember. The converse of a statement. If I want to make the converse of a statement, all converse, inverse, contrapositive are moving stuff around in the statement. The converse of a statement switches the hypothesis and the conclusion. It just switches the two. So you might want to write that down. Switches hypothesis and conclusion. Very important. Switches the hypothesis and conclusion. Guaranteed on the final exam, there's a question that's worth like, I can't remember what it's worth, like 10 points or something. One question. And this is what it is. It gives you a statement. Might even be that exact statement right there. I can't remember for sure, but it gives you a statement, and it tells you to find the converse, inverse, contrapositive of each. So all the converse does is switches the hypothesis and the conclusion. The inverse. The inverse goes back to the beginning, and instead of switching them, what that symbol mean? What did we say it meant a few minutes ago?
Negation.
The negation. So it makes it the opposite. All right? So it leaves them in the same order, but it takes the opposite of the first one and the second one. So it just makes, or let's even write it this way, negates hypothesis and conclusion. It negates the hypothesis and the conclusion. It negates the hypothesis and the conclusion. Leaves it in the same order but negates it. What's the contrapositive do? Look at the original statement. What did it do to the original statement? Switches it and negates it. So the contrapositive switches it and negates it. Wade's going to be upset when he doesn't have this stuff written down and he can't figure it out on the next test. So let's go back to this right here. If two angles are vertical, then they are congruent. See how smart you are. Two angles are vertical, then they are congruent. What's our hypothesis again? Two angles are vertical. What's the conclusion? They are congruent. What's the converse of that statement going to say? If two angles are congruent, then they are vertical. Very good. All right? Now, the other part that you're going to have to do when you do that is they're going to ask you if it's true or not. If two angles are congruent, do they have to be vertical angles? No, so that would be a false statement. All right? How about the inverse? Let's do the inverse for that same statement. Remember, you leave it in the same order, but you make both parts the opposite of what they were originally. If two angles are not vertical, then what? They are not congruent. So you got these two angles, they're not vertical angles. Does that mean they're not congruent to each other? No, that's a false statement also, isn't it? Because could I have two angles? Those two angles are not vertical, right? But could they still be equal to each other? Yeah, they could be. You know, this one could be 40 and this one 40. The contrapositive. What would the contrapositive say? It switches them and negates them, right? So what's it going to say? If two angles are not congruent, then they are not vertical angles. The contrapositive is usually the hardest one to decide whether it's true or false. I'm going to tell you this, and you probably want to write this down there. 99.9% of the time, if your original statement was true, guess what you know about the contrapositive? It's true. So, if the original statement is true, then your contrapositive is probably true. Because the contrapositive gets a little, you know, when you write it out and stuff, it gets a little confusing. So 99% of the time, if your original statement was true, the contrapositive is also true. This right here, conditional statements, converse, inverse, contrapositive, two of the most important things that we're covering today. All right, logically equivalent. All logically equivalent means if this statement's true, they're equivalent to each other. If this one's true and this one's false, they're not equivalent. Right? That's what logically equivalent means. So if two statements are both true, then they're equivalent. If two statements are both false, they're equivalent to each other. Biconditional. All definitions, if we were to grab my dictionary over there, all definitions should be biconditional. And what biconditional means is the original statement is true and the converse is true. So it means you do this to it, you get something true, the original thing was true. All right? So when we did this one, two angles are vertical, then they are congruent. Would that statement be biconditional? No, it didn't work, did it? The converse wasn't true. So it wouldn't be biconditional. When something's biconditional, you might see something like this. It'll say something like, if, it'll say something like Fred, and it'll give you this. You ever seen that word before? IFF? Probably not, right? What it means if and only if. So Fred, if and only if Joe. What that's saying is we know it works both ways. If you have Fred, then you know you have Joe. Or if you have Joe, you know you have Fred. So that's what the if and only if means. And that's how you write a biconditional statement, is by using that if and only if sort of in the middle of it. So if I was going to do it with this one, which it doesn't work, two angles are vertical if and only if they are congruent. All right? That's a biconditional, or how you would write a biconditional statement. All right, flip over to the back side. We got to pick up the pace a little bit here. Truth values of these conjectures. This is the part David's going to make sure he's up now, because if you don't have this stuff written down on these examples, you will not get credit. All right, so the first one, I switched that, right? Because I don't know, I wrote conjectures. I don't even think I wrote it, I think I copied it off somebody else and I figured out, hey, that's wrong. That should say conjunctions. What words does conjunction use again? And. Alright, and a disjunction uses or. Alright, so these first ones are ones with and. Well, if they're with and, then you know that what has to be true for the whole statement to be true? Both have to be true. Alright? So on this is what we're going to do. The first one they've already done for us. P stands for a hexagon has 6 sides. Q stands for 5 is an integer. R stands for 7 plus 4 equals 15. Are all those true? Only in Max's world is 7 plus 4, 15. So on this first one, it says P and R. Well, we're going to write that out. A hexagon has 6 sides and 7 plus 4 equals 15. Does a hexagon have 6 sides? So that part's true. Does 7 plus 4 equal 15? That part's false. What's that tell us about the whole statement then? It's all false. So that was just an example that they'd already done for us. All right, this one, that's the symbol for and. So we're saying Q and P. Q is 5 is an integer. Is that true? Is 5 an integer? Yeah, so that part's true. A hexagon has 6 sides. Is that true?
Yes.
What's that tell us about the whole statement? It's true, and that's what you need to write in there. Then that whole statement is true. Some of these, when you get to the homework, you'll have to write out this part yourself. You'll have to write out the sentence and then make that decision. All right? Here, I've already done it for you. On the next one, what did I do? I chicken out on this one. If I was to write that just out in regular form, it would be P, our and symbol, negation, Q. So it looks something like that. Well, P is a hexagon has 6 sides. That's true. 5 is not an integer. That's false. So what's that tell us about the whole statement? It's false. Whole thing is false because one part of it was false. With a conjunction, both parts have to be true for the whole statement to be true. Somebody read this one to me.
Negates R,
Or not R,
not R and Q.
not R and Q. So we're saying 7 plus 4 does not equal 15. Is that true or false? That's true. And 5 is an integer. True. So what's that tell us about the whole statement? Whole thing is true, if I could write very well. All right, for disjunctions, what's different about a disjunction? Uses or. All right, so let's run through these. This is the first example here. Complementary angles have a sum of 90. 25 plus 100 is 75. Vertical angles are a linear pair. Are vertical angles a linear pair? No. Remember, if you have your angles here, these are vertical angles. A linear pair are the two that are neighbors to each other, right next to each other, right? So we know that this one's false. We know that that one's false. Complementary angles have a sum of 90. Is that true or false? That's true, isn't it? So now let's look at it. P or Q. So P is complementary angles have a sum of 90. Is that true or false? True. Or do we even have to go any farther?
No.
If we know that that first part's true and it's got the word or in it, what's that tell us about the whole statement?
It's true.
It's all. Did I do something wrong on that one? This part's false. Oh, I see. I'm looking at the last word. So the whole thing is what? True. The whole thing is true. I think it's already written in there for you. I was looking at just the last word and thinking, why did I write false as the answer? But that wasn't the answer. The next one. Remember, this is a symbol for or. The V. The upside down V is for and. This is a disjunction. The other one's called a conjunction. 25 plus 75, or I'm sorry, 25 plus 100 equals 75. True or false? False. Vertical angles are a linear pair. False. What's that tell us about the whole statement then? It's all false. All right, flip over to the third page. On the third page, did you get all that way? False. On the third page, looking at this Venn diagram, I'll give you about 2 minutes. Read the questions and try to answer them. Read the questions, try to answer them. Guarantee you miss them. I don't have much faith in you, do I? It's not that I don't have much faith in you guys, it's that I know the questions and I know how you guys look at Venn diagrams. And it's not completely correct. David's thinking he's going to get them all right. You don't think so?
I'm already confused.
Does it say what? 25. If you look up here, you can sort of see it a little better, maybe. 25, 9, and 11. All right, let's try. It says the Venn diagram shows the travel methods for people in a particular company who travel for business. How many people travel by plane and train? What's the key word in all of that? So it has to be that they, and this is where you probably messed up in the past, because I'll guarantee a lot of you put like 45 on that. Which one's the correct answer? 9.
Hey, see what in your hole.
So, because what has to happen here? It says and, that person has to do both. Both parts have to be true. How many people travel by plane or train? 36? So Joe is right here. He's in that little green part right there. See, travel by plane? Also, that part's true. For or, what is it? 45. Gotta add them all. So even though Joe travels by both of them, does that make it false for him? No. Two false, or just because it's true for both, two truths don't make that false. All right? You just add them all up, because even Joe travels by one or the other. How many people travel by plane and not by train? 25.
Oh, okay, yeah.
That should have been the easy one. You guys missed the easiest one.
I didn't, okay, yeah, because he also traveled on the train.
All right, so these people don't count because they traveled by train, right? And we want to know how many people traveled. Remember, it's got to be and. So how many people traveled by plane but didn't take the train ever?
Dang it, I almost got it all right.
All right, so be careful with those, with the words and or. I'm sure you've had teachers in the past who have told you not quite the right way to answer some of those. All right, truth tables. Watch carefully on this first one. I'm going to do it. This explains to you how to do a truth table. We're going to go through it sort of quickly. You're going to do these truth tables the same every single time. Make sure you fill them in, all right? When we're done with this, we're not going to know whether the statement's true or false, because do you have any idea what R is? No, in the real world, you don't know if R is true, you don't know if R is false, all right? So what we're going to do, since we don't know if R is true or false, we're going to do this. We're going to say it's true. We're going to say it's true. Then guess what these last two are going to be? False and false. If you've ever taken a true-false test and you wanted to go down through and see, all right, if I just guessed at all of this, what's my chances of getting all of them right? All right? It's about 50-50, right? So you'd do something like this. You'd say, okay, I could have answered true on the first one, could have answered false on the first one. I could have answered true on the second one, true on the second one, right? So this is the first question, second question. Now, is that all the possible ways you could have done it? No, and that's why we have to have more of them here. Okay? Because you could have went true, false, true, false. You could have went false, true. You could have went false, false, so on and so on. So we need all those possible outcomes, and that's what we're doing here. How about Q? Let's skip over to Q. Well, if I said R was true, Q could be what? True. If I said R was true, just like over there, Q could be what else? False. We want to match them up. So true, 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 false. That's all the possible outcomes for that, right? If you answered true on R. What's going to go here, you think? True. How about here? False. Now that's probably the hardest part. Not R. Well, if you said R was true, then not R has got to be what? It's got to be false. Not R is true, then, or I'm sorry, if R is true, not R has got to be false. What's these last two going to be? True, true. Now what you want to do from all that, you take those, what's this symbol tell us this time? And. So both parts have to be what for this out here to be true? True. So we look at these two, we got a false, we got a true, what's that tell us about the whole statement? It's false. We got a false, we got a false, what's that tell us? False. Don't think that two wrongs make a right. Again, think about your mom. David goes home and he doesn't take out the trash and he doesn't feed the dog. He said, but Mom, I didn't do either one of them, so that makes me right. Yeah, I bet your mom goes for that, right? What's a true and a true tell us about the whole thing? It's true. True and a false? False. Which one is it? False. False. Remember, both parts have to be. What's the odds on this? If this was a true-false test, what's the odds that you're going to get them all right? 1 out of 4. 1 out of 4. All right, 25%.
That's not very good odds.
Nope. All right, try this one real quick. You got about 4 minutes. Try to fill it in. I'm going to give you about a minute or two to try it on your own. So try to fill it in. Hopefully you can at least fill in the first one. First column. Just like the other one, right?
Sure.
And hopefully you can fill in the Q column here.
How do you do the Q again?
How do you do the R? Somebody help us out. What do I put in the R column?
I put true.
True, true, false, false.
And then the Q.
I would do this first column that same way every single time so that you don't get confused. And then for Q, you say, all right, if R was true, Q could be what? True.
Oh, okay.
If R was true, Q could also be. If R was false, Q could be what? If R was false, Q could also be.
False.
Now, how do you do the not R? It's the opposite of whatever you had over here. So false, false, true, true. Now all we want is the not R in the Q column. That's these two right here, and that's going to help us make our decision at the end. Remember, what's this symbol? Or. So what has to be the case? Do both of them have to be true? Just one of them. So is this first statement true or false? True. How about the second one? How about the third one? True. Fourth one?
It's true.
Now what's the odds of 3 out of 4 of the whole thing being true? Don't make those truth tables harder than they actually are. All right, that's your assignment. It's on 2 separate pages, page 72 and page 78. I don't see you till Tuesday. I don't see you till Tuesday, so make sure.
Oh, Monday's the
Monday's the morning day.
Monday's a brown day.
Make sure you don't forget.